This is video 3 of looking at problems that are related to the binomial theorem. And in this one, we're going to be looking at just example 2. And so this one says find the 7th term in the expansion of this binomial, the quantity 3x minus 4y to the 10th. So I've written here the information from the first page where we talked about in the expansion of a plus b to the n, that the general term is just this, n choose r, a to the n minus r times b to the r. And remember that that comes from right here, right? That's what the term is. This is just telling us we're adding a whole bunch of terms up. And then remember that our value of r is always 1 less than the term number. And I always remember this by thinking about if I want term number 1, the value of r is 0, right? We can see that right here. So I have to subtract 1 from the term number to get the r value. So if I want the 7th term, then r is going to be 7 minus 1, which is 6. And then make note of the fact that n is equal to 10. And so our general term then is going to be, our 7th term, which is what we want, is going to be 10, choose 6, subbing 10 in for r, or 10 in for n, 6 in for r, and then we're going to have a to the n minus r. Well, a is 3x, that's the first term. So 3x to the 10 minus 6 power, which is 4. We're just doing 10 minus 6, that's 4. And then we're going to have times our second term. Now be careful in this general term formula, remember that what we're expanding is a plus b to the n. And so we have to think about this as being plus negative 4y. So this is going to be minus 4y to the 6th power, to the r power right here. And so now it's just a matter of expanding that out. And I'm going to let you double check these, but 10 choose 6 is 210 times. Now if I take 3x to the 4th, I have to take both 3 to the 4th and x to the 4th. And 3 to the 4th is 81. So we get 81 x to the 4th times. And then if I take this product to the 6th, I have to take both the negative 4 and the y to the 6th. Negative 4 to the 6th is 4096. And then I get y to the 6th. And so now if I multiply together 210 times 81 times 4096, I end up with 69672,960. Again, I'll let you verify that, times x to the 4th times y to the 6th. And that's our final answer. Now notice that we didn't have to expand the whole thing out and find all 11 terms of this expansion. We only wanted the 7th term, so that's why we're just using that general term formula.